My presentation will consist of three parts. The first is the policies related to energy conservation and low carbon buildings. And the second one will be the case examples of the best practice in energy conservation and the low carbon buildings. And the third one is the future work prospect. So the first part is the policies. In September 2020, China aims to peak its carbon dioxide emission before 2030 and achieve carbon neutrality by 2060. And over the past 2 years, almost all regions and the government departments in China have made solid progress in implementing key tasks of carbon peaking and the neutrality goals. And in turn, the 1+N policy framework has been established. And now China is actively deploying 10 actions of carbon peaking in industry, buildings, transportation, and some other sectors as well. The building sector is the key area of carbon peaking and carbon neutralities in China. In the formation and release of relevant policy framework, China encourages the development of energy conservation and low carbon in the building sectors. And some of the typical policies examples are listed here. The working guidance for carbon dioxide peaking and carbon neutrality in full and faithful implementation of the new development philosophy is proposing to accelerate the development of energy conservation and low carbon buildings with great efforts, and also continuously raise the energy conservation standards for new buildings. And the action plan for carbon peaking before 2030 is also proposing to focus on implementation of carbon peaking actions in urban and rural construction, and also promote the large-scale development of the low carbon buildings. And the 14th five-year work plan for energy conservation and emission reductions is also proposing to raise energy efficiency standards for buildings and promote the energy saving renovation of the existing buildings. And the Ministry of Housing and Urban Rural Development has also issued several documents planning to build more than 50 million square meters of buildings with ultra low energy and near zero consumptions by 2025. This is to speed up the large scale development of low carbon building. And the last, the opinions on promoting green development in urban and rural construction is proposing to strengthen the policy support in financing, planning, and construction areas. This is to enhance also enhance the large-scale development of high-quality green buildings. So apart from these central government policies, our local government has also issued similar documents to support their own green building development. So therefore, it's fair to say that China considers energy conservation and low carbon development in the building sector as a vital content for its carbon peaking and neutrality goals. In the second part, I will be presenting two cases of the best practice in energy conservation and low carbon buildings. Just for your information, these are from the second round of the international top 10 selections. So the first case is CABR demonstration building with near zero energy consumptions. The demonstration buildings is located in Beijing, and it is a 4-story office building covering a total area of around 4,000 square meters. So to address the core problem of energy conservation buildings in China, this building having the design principle of passive priority, active optimization, economic and practical. It has integrated and displayed 28 world-leading energy conservation and environmental control technologies for the buildings. So the building also brought the advantage of intelligent operations management into play. So fully mobilized our energy conservation technologies for buildings to operate in coordination and therefore achieve the near zero energy consumptions. And as for the energy conservation path, excuse me. The first is the building enclosure components. This includes the installation of VIP vacuum insulation board, low E glass, the use of door bucket design, and liquid flashing. And these technologies improved insulation performance of the exterior wall and window. And the second is heating and refrigeration technologies. The use of ground source heat pump, water loop heat pump, and water cooling, magnetic suspension refrigeration. These are to improve the overall efficiency of the refrigeration and heating systems. And the third is the end-of-pipe technologies. These involve the cooling and heating of radiant ceilings and floor, and also temperature and humidity independent control, and the fresh air heating recovery. And next is the renewable energy application involving the ground source heat pump, solar heating, and vacuum collectors, and also BIPV, the building integrated photovoltaics, to make full use of the solar and geothermal energy. And the fifth is the intelligent control systems. So the use of energy management system, lighting control system, and building control system, personnel information induction systems to achieve the control and optimized operation of the system and also the equipment. As for the benefit of energy conservation and carbon reduction, the annual operating power consumption of this building is 34.2 kilowatt per hour per square meters, of which the air conditioning and lighting systems is 21.6. So in the winter, 65% of the heating load is provided by the ground source heat pump, and 35% is by the solar energy systems. Whereas in summer, 80% of the cooling load is provided by ground source heat pump, and 20% is by the solar air conditioning systems. Compared with the energy consumption of the similar buildings, the CABR demonstration building can save more than 80% of energy and reduce CO2 emissions by 225 tons per year. But however, the total cost of the unit area of the building is about 5,000 yuan per square meters. This is a little bit higher than other average buildings, but the payback period of the incremental cost is estimated less than 10 years. The CABR building is the first near zero energy consumption buildings in China, which has realized the transformation of building energy consumption control from path constraint to effect constraint. And it greatly improved the performance of the performance and application level of the building parts and products. So based on the experience in the design and the operation and management of these near zero energy buildings, relevant departments have studied and formulated the technical standards for near zero energy consumptions, which was playing an important guide and support role in promoting the relevant works across China. And the second case is Passive House Technology Experience Centers in Sino-German Eco Park. It is located in Qingdao, Shandong Province, and has the function of meeting rooms, exhibition hall, and office, and also experimental apartments. It has a gross area of around 13,000 square meters. And in terms of technical aspect, a series of passive technologies and green building technologies are adapted. First, in the design of the enclosure structure thermal performance, selecting materials with high performance maintenance structure, controlling the external wall and roof heat transfer systems, and also other window is using aluminum wrapped wood 3-layered vacuum glass. And second, for the renewable energy technology, is the reasonable use of ground source heat pump systems, and also solar thermal and photovoltaics, and also the roof graining. And for air conditioning optimizations. It is to optimize the air conditioning efficiency combined with the temperature and the humidity independent control using different water temperature to provide cold and heat source for fresh air unit and cold beam systems. And for building airflow organization is the reasonable design of the airflow organization to improve the quality of the cold and hot environment in the public areas. And in terms of management aspects, it is, excuse me, it is first the center adapts the world leading intelligent control systems, including TRA ECCJ and building control management platform design CC, and also based on the beam systems and BAC night communication protocol, which helps the optimization of energy consumption strategy. And second is the setting up of 4-level energy management systems enables the center to manage energy usage for rooms with different types and different areas, and also different functions. And third, of course, the constant measurement and management of key energy using equipment is always important. And last but not the least, a series of operation management systems are formulated, including energy, resource, and human management. As for the benefits, the energy consumption of the center is about 30 kilowatt hours per square meters, which is 85% more energy efficient than that of similar buildings. Among with the energy consumption of HVAC plus lighting terminals is 19.8. And the energy consumption of buildings per unit area is only 55% of the average value of similar public buildings in Qingdao. On the premises of meeting the first level comfort level, the annual electricity consumption is saved about 720,000 kilowatt hour, and the annual carbon dioxide emission is reduced by about 250 tons. And this project has a great demonstration significance because it has obtained the architectural award of passive buildings with ultra low energy consumptions, and also obtained Samsung's certification of green buildings in China. It has become the single passive buildings with the largest volume and the most complicated function in Asia, and certified by the German PHI authority. Therefore, it is exerting a positive demonstrating effect on the technology promotion of the passive house in the cold area, and facilitating the gradual establishment and the implementation of the technical standards for buildings with near zero energy consumptions in China. So, and the last part is the future work prospects. Developing green and low carbon buildings is of vital importance it's vital significance to achieve the goals of carbon peaking and neutrality. And in the future, China will actively launch the actions and carry out tasks in the building sectors to promote buildings with ultra low energy consumption and buildings with near zero energy consumption. And moreover, China is now taking the lead in the third round of international top 10 selections. And as a member country of the top 10s, Japan is very much welcomed to also actively engage in the selection, which relates to the selection of the best energy conservation technology and also the best energy conservation practice in the building sectors. And other countries are also welcome to make in-depth exchanges with China and other top 10 members on energy conservation in building industry. And that's all for my presentation. Thank you very much for your time.